good stuff. Make sure we can see some code. And we'll wait for some adverts to run out. Now, you'll see it tonight. It says Unprepared Chill Stream, and that is incredibly accurate because I have absolutely no idea what it is that I'm going to be showing tonight. Instead, what I'm going to be doing is sort of panicking a bit live in front of a Twitch audience. So we'll see how it goes. Good to see we've got the regulars in the chat already. Danicron's here, Magetsub's here, Standard Int is here. Morris is here, Dragon Eye is here, hello everybody, and of course there's been some big news about Twitch today, hasn't there? That's a bit of a problem, and it might be, it's also a problem here if we're not seeing anything or nothing is working. The reason being is because, well, I guess Twitch is kind of finished, right? It's had a bad run today. Firstly, also, yes, my apologies for last week, and I guess this week. Last week I had to go and sort out some work problems. I had to go and pick somebody up from the airport in the middle of the night, so I couldn't do the Tuesday. And then on the Wednesday, X10 was not very well, so I had to deal with that instead. And not only was she not very well, but then when I actually started to sit down and prepare to do the live stream, my radiator pipe burst. So it was a very busy night that night. Right, Standard Int, hello, yes, Morris, hello. So tonight, really, I've not got a huge amount to sort of show. I normally try and theme each episode, but I thought tonight I'll just show a few things that I've been sort of dabbling with. Not having that much time to code over the last couple of weeks, I've sort of been trying to build up various tools and libraries which I think I'm going to be adding into the Pixel Game Engine. Well, some of you may have heard whispers about Pixel Game Engine 3. Well, I can confirm there's a specification in the works, and it's going to be a little bit different to the Pixel Game Engine that we know and love. So there's a bit of a risk involved in that, and I'm not going to I'm not going to go into too much detail right now about it. But I think it's probably going to go to Pixel Game Engine 3 and then stay at Pixel Game Engine 3 for the rest of its lifetime, I would think. Rock3Y, hello. Shader time. In PG3, possibly. The idea fundamentally of PG3 is there's going to be a lot more sort of abstraction going on, so there'll be a lot more implementation independence. But I'm hoping that it will retain the charm and simplicity that is Pixel Game Engine that we know and love. But I'm not going to delve into that too much. TGD, good evening. Yes, hello. Null Alternative, yeah, we've had the Twitch leak today, so I've been, my phone has been pinging with people trying to access my Twitch account. Well, I'm guessing it's not people, I'm guessing it's just bots. So it does happen. Kanwanagaski Yoko. Whew. Hello. So, for those expecting sort of a full-on code fest tonight, well, we're going to have some code, we're going to show some stuff, but I've really not got any sort of plan of what it is that I'm going to show. The last episode that we did, we looked at some trapezoidal motion, and I carried on looking at trapezoidal motion. This is part of the problem, you see. I had an idea, and then I thought, you know what, I'm going to run with it for a bit. So I started creating a class here, called a linear motion profile to sort of encapsulate the trapezoidal motion stuff that we were developing. And it was through developing this object that I realised that there's some problems with the trapezoidal motion that we were implementing. In principle, you kind of want to lerp the motion. Oh, hang on. We've got Starfreak. Oh, resubscribe. Thank you very much. And Morris also resubscribed. Thank you very much. Morris has been a subscriber for 6 months. Starfreak has been a subscriber for 2 months. Thank you. It all helps. In fact, it goes towards buying Garibaldi biscuits. And I said I would eat a Garibaldi biscuit live on stream. And if you some proof... this is a pack of Garibaldi biscuits. They're from Jack's. Now, for those that don't know, and maybe in the UK people don't know, Jack's is a brand set up by a popular supermarket chain called Tesco to compete with the cheapo supermarket chains Aldi and Lidl. And to be fair, they do a pretty good job. It's exactly the same stuff that Tesco produce, just at half the price. Twitch is now open source software. Yes, I guess it kind of is. Yes, and Danica said, yes, not sponsored at all. Basically, I'm cheaping out on my biscuit selection. Anyway, this is a Garibaldi biscuit. I don't know if you have these in other countries. It's a very thin biscuit filled with currants and raisins, and it's kind of sugar-coated. I think they're very tasty, but not a lot of people like raisins and things, so... Yeah, this is the kind of quality content you can get on my OnlyFans page. Raisins. No, raisins are great. Anyway, so I'll probably not talk with my mouth full. You don't like sweet biscuits? All biscuits are sweet. If it's not a sweet biscuit, then it's bread or... I don't know, it's a cracker. Breadledge, hello. Yes, raisins are good, Game Finger. You're absolutely right. Literally unwatchable. I'm not surprised, yes. Run away, run away. So, in the last episode, we sort of looked at how we could do all of these complicated calculations to derive the various times required as part of a trapezoidal motion profile. But it turns out, in reality, in your games, you don't care so much about sort of how to instantaneously travel across the screen. A far better way to do it is to know your start location, know your end location, and simply lerp across those points with the right amount of time required. So you still need to do the calculations to calculate the time for the different sections, but the way that you approach solving the problem changes. So anyway, I'm going to... Oh, that's really zoomed in. I'm going to be releasing these code snippets, linear motion profile, as part of a PegX that I'm working on called GameKit. At least that's a working title name. And the idea is to provide a bunch of utility classes that allow you to sort of quickly get bits of game up and running. And it was born out of inspiration. For the Jam, I created this Fleur game. And one of the reasons I can create these things quite quickly is because I've got a fairly large body of code that already exists. And it's I think it's time to let some of that out of the bag and let people use it. It also makes the Pixel Game Engine, the one thing it's lacking is sort of a utility library full of useful bits and pieces. So I'm going to be trying to sort of push that sort of stuff out as well. Hopefully, anything you hear me talking about Pixel Game Engine now will sort of automatically apply to any Pixel Game Engine 3 stuff you might hear about in the future too. So yes, I'm going to create a various set of these motion profiles so you can have things easily moving around on the screen. Now I've got a feeling that if I try to run this, it's not going to work. We will see. I think it's sort of halfway in development. It's how my brain's been working over the last week. Does it even compile? Let's see, let's set that as the startup project. So I've no idea what we're going to get here. That's why it's a fairly relaxed stream tonight. Let's just run that and see what happens. So I think it's the demo that you kind of saw last time. Yes, it is. But now it's far more constrained, and it's entirely frame rate independent now. And it behaves precisely. If you remember before, there was a... Well, maybe you didn't see, but what would happen, because we were integrating per frame, there was a little error and discrepancy behind where the object actually ended up on the line. And it would do things like never getting to its maximum speed properly. It would always hover around. It would get to the end location, but it wouldn't be absolutely spot on. So instead of now calculating it per frame where it should be, I go ahead and calculate where it should be at any point in time, and then use a time interpolation along its length to actually give me the accurate position and velocities of the object. And this is very useful for moving spacecraft around the screen. So it's a slightly different thing. Narosi, hello. GameKit for Apple. Yes, well, I don't know. I've not got a name. It's my sort of working name. I got regular Ngon code lying around. Shall I contribute to PegX? Now, standard in. Yeah, that's a good point. Because in a few episodes ago, I did mention that I would like to create a PegX which is full of community contributed stuff. Basically, it's open, it's moderated. We'll let the community just contribute to that PegX and have all the weird and wonderful routines, and you can all optimize and argue with each other about who's the best for doing certain things. So yeah, I think that's the sort of useful thing that we would have in a library like that. I think it would be great to have sort of community PegX. It just be full of bonkers algorithms that people work on. Because particularly on the Discord server, you do see quite a few people writing code and demonstrating things. So I'm going to be creating this sort of game enhancement PegX, and there's a few things that are going into it. So another one that I'm working on using these linear motion profiles is going to be a set of animation tools. Now, I know Saladin has created a animation class, his own PegX, and it's very useful, and lots of people are using it, and nobody's complaining about it. It's a good bit of kit, but I think it's time to sort of upgrade it a bit. So I don't know if Saladin's actually watching this. I don't think he does today, but it does need. It has a problem that every time you create a sprite, it reloads the graphic. So my intention is to have something similar, but the actual source of the graphics is independent to how the animation is structured. So you only need to load the sprite sheet once. Domis PL is gifting subs. Oh, thank you very much. Very kind of you. Domis PL. Apostolisk, hello. Rosso, hello. Nanoic, hello. Nanoic 1 got a bonus. So how many of you have got brand new Twitch accounts after today's activities? That's a big problem for Twitch. I think that's a scary problem for Twitch. I hope it's not too damaging for them. You changed your password. Hopefully everybody has changed their passwords and all using a two-factor authentication. I think that's an important thing to do. Yeah, no, I think if you do actually have sort of links across these things, yeah, everything's got to change. I'm very surprised yet, and I've not really seen anywhere where Twitch have sort of said it's happened, so we don't know. Domis PL, this is a thank you for your YouTube coding videos. Hey, no problem. It's very much appreciated. It keeps the community going, and it keeps paying for Garibaldi biscuits. That's an important donation. Well, tonight's Twitch stream is going to be unlike the YouTube videos. Now, I was intending on doing a YouTube video last weekend, but as I explained, my little one wasn't very well, so it didn't happen. Have to remember I'm live on screen and not to eat biscuits. But you can't help it. If you've got biscuits in front of you, you've got to eat them. So my attempt here at doing animation is to sort of describe what a frame is and go through the sequence of frames. And this is standard fare for animation. But you'll notice at no point in my animation classes do I actually refer to the graphic as such. The graphic itself is abstracted away. So when you come to render, then you can actually supply the graphic. So in effect, you can reuse the animation, but with different graphics in the background. And that's quite a common thing to want to do when you're rendering character sprites. They usually all have the same actions in the same locations on the sprite sheet. The only thing you want to change is the sprite sheet source. So that's hopefully going to accommodate that. The one thing that Saladin also does is he accommodates individual sprites being loaded as data sources for his sprite PegX. I'll need to do something similar as well. I've not got that far. Also, as part of the kit, I thought I would add in a camera, and so I wonder if I can actually run this. And this is the problem. So I start simply coding. Oh, I'm coding trapezoidal motion. Right. Okay. Now I'm going to code this camera. Oh, hang on. But to demonstrate the camera, I need animation. So it sort of never ends. It becomes this bottomless pit. So the idea of the camera is to provide a simple method of having cameras in in-game worlds. I'm just wondering if I can boot this up. Let's see. Camera control set as start up project. Is there an easy way to reverse the order of the animations? I'm trying to make a simple time travel game. Yeah, it's incredibly trivial. That's the plan. So at the moment I've got repeat and ping pong. So ping pong is go forward, then go backward, then go forward, then go backward. Yeah, I could actually have it quite easily handle going reverse as well. So I'll actually throw that in. Reverse as a mode, and we'll chuck that in later on. Yeah, it's a good one to have. I hadn't actually considered that, but it's eminently doable. I think it's a nice thing to have, these sort of utilities, because it sort of takes the pixel game engine to the next level. Anyway, so that compiles. So what have I actually got? What is it that I'm actually demonstrating now? I think on this one, it's not the most interesting of visual demos. Camera control. Okay. So the blue dot is the user agent, which I think is controlled with the W, A, S, and D keys. And the red rectangle is the screen. So I'm you wouldn't normally see a big red rectangle like this. It represents the viewing area. Now you might tie, for example, that viewing area's top left to a transform view or something like that in your world space. How you do that is up to you. So this is implementing what's called a lazy follower. Oh, and it's bounded as well. So you can't go out of a certain range that you've set. Because I thought that would be useful for Metroid-style platform games where you want to just scroll along a fixed horizontal axis for a bit and then unlock it and do vertical, that sort of thing, rather than just letting it freeform. So that's a lazy follower camera. That's one type. Let's have a look at a different one. I have to remember what they were called. I think I wasn't even setting them. I was just setting them by default in the camera class. So what have we got? The ones we've got so far: simple camera. Okay, simple camera is what you'd expect it to be. It's just going to be. It's just fixed, right? There's no smartness at all, other than the boundary control is still applied. And if the object that you're tracking exits the visible space, it actually returns a boolean to say it's not visible anymore. That might be useful for something, I don't know. So it's free, why not? We'll have that. And then there's also this one, and I think this is the one that everybody's going to use. Edge move. This is what you kind of see now in more polished titles. This is the sort of effect that you want. So the idea is that the object sort of only moves the camera around when it approaches the boundary in some way. So you're free to move around in the world space, but you sort of push it along a bit as you move around the world. And the idea is you can attach this rectangle to whatever sort of transformation you're using to view the world, and it will handle it all for you. And it has a rather clever, well, I think rather clever, but a nifty bit of code that you can specify when you're attaching the camera to something. We were talking about this in C++ chat on the Discord. What do you want the camera to be attached to? Well, I wanted to be able to attach it to an object or attach it directly to a coordinate. I use both a lot, and so we had to look at the code for handling those two situations. And it ended up being a little bit more complicated than you think. We were discussing reference wrappers and all sorts of interesting C++ techniques. Ultimately, though, the right solution was to use a pointer. And that's what we ended up doing. So I'm just looking here. So set target here. This is where we have the instance of it being an object. We just pass it in as a reference. So the thing that it's following can change elsewhere in the program. When you come to update the camera, it just updates its location. If you want to specify the object directly, though, as like a constant literal almost, then it needs to store that locally. So it creates that in a local variable, and then creates basically sets the reference to that local variable. So that's a nice way of handling this situation. So the camera can then become sort of autonomous. Oh, sorry, excuse me. Autonomous in a way. It can just sort of follow whatever you want to point it at. So there's going to be a various set of camera motion routines as well, and that's why I was feeding into this linear motion profile stuff. Right, let's catch up with a bit of the chat. The recursion meme applies here, I think. Maybe. A single mode would be useful too. Looks like Undertale. Reference to a vector. Your solution is simple and exactly what you needed here. I think so, exactly. Yes, so Starfreak was involved in some of those discussions too. So I'm getting a load of pings on Discord. Is something going on? Usually get a load of pings when there's trouble happening. Not that we get much trouble on our Discord. So yes, there we go. So it's the beginnings of a kit of reusable parts. Now, I don't know if Saladin does watch these things, but some of you will remember I also started work on an editing tool, which is actually a full GUI tool. It wasn't done in the Pixel game engine, and that allowed me to do 2D levels and construct them quite quickly. I think part of my game kit provision is going to actually support things like, it's really going to be biased around tile-based games. And how we can have tiles interacting, handle the collisions for you, throw out events when certain things happen, really just to allow people to get up and running with simple games pretty quickly. And I think that at that point I know kind of Pixel game engines where I want it to be. So yes, the cameras currently at the moment, because these are all just prototypes, and basically I call them brain dumps into a file. I've got constants and magic numbers and all sorts in there. That will all disappear by the time it actually gets out there. It'll all be customizable one way or another. Then I thought, well, what other interesting programs have I got to show? Because I've got a few. And one of them was this Nanobots. Now, I wrote Nanobots. If some of you that are on Twitter, there's a programmer called I think is it Frank Force. His Twitter handle's Killed by a Pixel, and he's into sort of generative art and golf-based JavaScript projects. And it's not very often that I sort of talk about other programmers, but I always find his work particularly interesting stuff because it's kind of golfed, and I'm always impressed with the end result. And so one of the algorithms he posted was something called Nanobots, and it was like beautifully simple algorithm, and I really liked sort of the end result. So in this little program here, I've got really nothing other than a set of points. The rest of this stuff is a transform view, so I can navigate around, and then I'm changing some parameters of the algorithm. So you just key held and whatnot, handle the pan and zoom, and really this is it. So that's the code. We go through a number of points, we do a little bit of trigonometry to some of the points, and some sort of weird step change in some of the parameters for the points. I ended up, and then I draw them. So I draw them as a single line. So there we are, Killed by a Pixel. So this is not my algorithm at all, but I thought I would implement it. And I actually sent it to him in the form of an script and compile of this, and he thought it was okay. We'll have a look at this and see what this does. I've got to remember how to drive it. That's the important part. So Q and W, A and S. Let's see what happens anyway. Right. Okay. Yes. Let's zoom in a little bit on this. So what happens is you get what looks like chaos. So it looks like a random noise pattern going on here. Let me make this screen a bit bigger. There we go. And as I change one of these parameters, you actually change the nature of how the noise develops. Now I've made it so you've got to follow. So this is a slightly different pattern, as you can see there. I'm going to change the speed a bit. So I think we had it. So if we slow it really quite slow, and get to see what it's doing. So this is like chaotic trigonometry functions creating these interesting loops. There we go. Let's go back up to, let's go to 0. So I think that's the sort of the start. And at some point it's just a straight line, right? It follows its thing. We'll go to 1. So 1 is a straight line. And oh no, 1 isn't a straight line. 1 is 1 a straight line? 1 might be a straight line. Oh yeah. So 2 draws not quite a hexagon. So okay, so let's take 2 and I'm going to speed that up. I could do with it being more persistent, I think, to sort of see where it goes in the world. But this is the same piece of code, just with a slightly different sort of arguments applied to it, producing a completely different chaotic shape. So let's go to number 3, number 4. So these ones just look like they're getting smaller. And Killed by Pixel went ahead and sort of classified sort of the first 256. And I thought, well, wouldn't it be cool to sort of interact with them live, rather than just looking at static images of them? Let's try and find something that's a bit more strange. I see, so that one's quite strange. Let's slow it down a bit. It might be a bit too persistent. That's why we can't really see what the pattern is. So that one's doing sort of loops and lines. Let's go to the next one. And they happen in sort of, yeah, kind of groupings. It's quite strange. Let's go to the 30s. Right, so 30s looks like the groups get a bit tighter. So this one does the 36 does a little sort of squiggle, and then takes a big shooting off line like that. And overall, they sort of follow these weird sort of trajectories. So I've sped this one up a lot. So this one kind of wants to stay where it is, but the overall trajectory is also an interesting pattern. I mean, I can play with this sort of stuff all day. It's probably not that interesting on a stream. Now let's just slow that down a bit because I'm losing that one. Now see this one behaves like some sort of stream here. This one's a spiral again. And I think you had to sort of get into the really big numbers and then you start to see really strange patterns going on. I think it's fantastic anyway. How crazy difficult would it be to implement a split-screen camera or an end-screen camera? I'm thinking of a case where a player needs to follow multiple characters at once or maybe local multiplayer. In Pixel Game Engine, it should be reasonably trivial because you could potentially just split the screen is just a sprite. So you're basically drawing to a sprite. So there's nothing stopping you drawing to two different sprites and then drawing those to the screen or even using them as decals. People always assume that actually updating the decal is so costly it's never worth doing. That's actually not true. Now the Pixel Game Engine right now, it's locked at 60 frames for VSync in my case, but the Pixel Game Engine is actually doing that thousands of times per second behind the scenes anyway to make things work. So it's not the most costly operation in the world. You want to avoid it, but certainly no problem at all. If you do want to live update sprites and then change the decal, yeah, you can go ahead and do that. I mean, I don't know why I just find this sort of stuff so fascinating. I like the fact that it's one piece of code producing, oh, look at this one, all of these different sort of interesting behaviors. There's so much about sort of numbers and maths that I think I have no understanding of. Oh, it was great. Chat was quite a while ago. Alter Ego. The one moving diagonally downwards to make a cool looking raindrop. Yeah, small amount of tile sprites were faster than decals for me. Gotta love emergent behavior is cool. So anyway, okay, that's why this is it's not that interesting, I suppose, if you're not into emergent behavior. But there's hundreds of these different patterns, and he went away and then categorized them all because some of them start to look like maybe I've got something chaotic going on in here. I don't remember them all being quite as sort of noisy as this, so I've got a feeling I've changed a parameter somewhere because the ones that he ended up categorizing, they look like little gears and sort of little mechanisms. I think it's because I must have been playing with some of the parameters. Totally useless, but lots of fun. I think that's important. You added an auto crop of decals and two transform views. Doing nested transform views is something I've done too. Space Thing actually does nested transform views for when you're placing the satellite stuff. It's actually complicated, and I think it's complicated to start reasoning about how it works. It does work, but it's not that trivial. I think we'll address that in an upcoming update to the transform view. Once I'd played with the Nanobots, I showed it to our guy called Lubitech on our server. He's not been around too much recently, but he's our sort of resident artist. And he then got excited about how to do spirographs. And so I thought, well, I'll have a go at creating a quick spirograph. I can't even remember how this gets set up, so I'll have a look. So it looks like spacebar resets something. The on-user create, I mean, there's nothing to this, is there? Literally nothing to this. Let's have a look. Let's just run it. Set as startup project. I think it was something I coded up in about 20 minutes just so you could basically see how do you implement a spirograph. A spirograph is this tool that we had when you were kids. So basically a set of gears, you put a pen in and it created interesting patterns. Now I can't necessarily remember how we drive this. That was one pattern. So I think if I change the nature of these properties, so it looks like V-arm. So this must be the length of the arm, a starting angle, and I've no idea what the third one is. So let's have a look at changing the length of some of these. So if I change that to a 4, for example. I think was I trying also to get like the fast Fourier transform implementation? Can't remember. That's not changed very much. That's not very interesting, is it? Let's change this. Let's change one of these up. Mix it up a bit with a different number. It could just not work. I have no idea what state I leave these programs in. Okay, there we go. So that one's nice. It's periodic. It actually found a solution that just ends up repeating itself. Let's change this one to 3, this one to 4, and I'm just going to set these to 0 because I've got a feeling that I was experimenting with how chaotic do they become. Oh, that one's not very interesting, is it? Simple shape. Is it that you've got to do the biggest arm with the biggest number? Let's try these backwards, see what happens. This is what I enjoy most about code, is just sort of dicking about with it, really. What happens if? It's good stuff. Oh. These ones don't actually seem to be particularly interesting. I wanted more of a spirography thing. So I think what I wanted was, let's just try it with, let's try and understand our own algorithm here. So I'm going to set that to 4, and that one to 4. That one to nothing, and that one to nothing. I'm going to have the biggest arm is doing, I don't know what these are, 4, and this one is going to be doing 1. So we'll set these to 0. So basically we should have a circle that's then transcribing lots of other little circles to it. Yeah, I can't remember what these numbers mean. What is the first number? Let's have a look. What was our structure? Length, speed, and angle. So speed, I think, we want this to be slow then, do we? 0.1, and this one we want to be large. Let's try that. Angle I don't think really matters. There we go. Right. We're understanding the algorithm a bit better now. So let's put in, again now, something like a 32 and a 16. We want this one to be 8 and this one to be, yeah, let's go for 16. Let's go and slow that one down. We'll go that just as a 1. Right, no idea. Like it. There we go. Right, what's going? Oh, hang on, we've got some chat. What's a decal? Is it the structure of this engine? How does it differ from a sprite? So yes, a decal is we store sprites in CPU memory, but decals are stored in GPU memory, so they're very fast for the graphics card to draw to the screen. And in fact, we use decals. I use them. People start using them a lot more now because the graphics card is handling them. You can draw a lot of them, and not only can you draw a lot of them, you can also manipulate them and distort them and change their lighting and their transparency because the GPU is doing all of the work. Basically, you get all of that behavior for free. The downside is a decal doesn't last more than 1 frame. It has to be redrawn every frame manually, whereas a sprite is persistent. I think I'm going to sneeze. Yeah, it's a simple texture because most of the drawing, if you want to draw a line in OpenGL, and I know this is a bad example, it's actually pretty difficult. And yes, you can use the draw line features and GL lines and that sort of thing. But if you actually wanted to, say, draw, I don't know, an ellipse or something that's a more complicated shape that you would raster, then you have to kind of do that either with a graphics shader, fine, that's an option. A set of vertices, that's another option. Have a texture of a spiral, that's another option. Or you can render it on using the CPU, which is very fast, and then upload that to the graphics card. Right, so that takes me on to finish with Spirographs. So what I wanted to show now was sort of what I've been working on most recently, and it's had an idea. Set up startup project. And I'm going to go to, this is a program, you can tell, this is how my ideas work. So this was actually when we were looking at how we could get rid of the artifacts in tiling transforms. And we were writing some experimental code, and I just took that code and then started hacking some more and more stuff to it. And so this is what I ended up working with last night. So there's going to be all sorts going on here, because it's basically two programs mushed into one. But the bit that I think I want to sort of get a little bit excited about is this here. And for a while now, we've been able to do sort of pseudo 3D graphics in the Pixel game engine, and I actually have a reasonably complicated PegX here called HW3D, which allows you to do actually full-on 3D graphics. So that package. When that gets released, that's full-on shaders. That's everything. Allowing you to basically just use the Pixel game engine as a rendering system with keyboard input cross-platform. So it becomes very much like Glut in many ways, or whatever the modern version is. But it occurred to me, actually, even in 2D games, quite often you want some lightweight 3D drawing. And so far that demand has been satisfied by doing the PegX 3D, which does all of that in software. So it's a software rasterizer. It's almost a carbon copy of the video series I made on the YouTube channel. Just all wrapped up in a nice format. And if you ever saw the Car Crime City videos, top-down city-based car crime videos, that was exclusively done using this software 3D PegX. Downside with software 3D, of course, is you can only do so much before your computer starts to chug. But it occurred to me, actually, could we utilize some properties of the Pixel game engine that are already there to draw actual 3D graphics? And I demonstrated this in the previous CodeZone episode, previous but two, I think, where we were looking at my jam entry, and I showed a cube spinning, and I was using decals to represent the size of the cube, and the function draw warped decal, which allows you to sort of manipulate those positions in 2D space. The downside to doing it with decals, and quite a few people have done this on the Discord server, they've used just 2D textures, distorted them to look like 3D surfaces. It looks brilliant, but you've not got a Z buffer. And that's a problem, particularly for beginners, because if you start throwing 3D graphics at the screen and you've not really got them sorted sensibly, very quickly they start to look pretty bad. I'm just going to finish off this bit of Garibaldi. Fez is a great game. I really like Fez. So I quickly sort of hacked together a function, and this stands for lightweight 3D draw triangles. The idea here isn't to provide a full 3D framework, it's to provide some sort of assistive way of drawing accurate 3D models in the ecosystem of the already existing Pixel game engine. So you're not talking shaders and you're not talking vertex buffers and all that sort of thing. But it's calculated on the hardware to an extent. And the way it works is you can set a decal mode called Model 3D. This may change to something else later on. I may have it so you don't even have to set this manually. But once you're in this mode, decals are rendered slightly differently, and we'll look at the Pixel game engine code for this too. But in essence, you set up a vector of 3D vertices, x, y, z. You set up another vector of 2D vertices, which are your texture coordinates, your u's and your v's, and you set up a final vector of colours per vertex. That's probably not enough, actually. Now come to think about how many I've got. 3 points, 3 texture coordinates, and 3 colours. That's correct. And then you can just throw that. Ignore this line for the time being. You can then just throw that at the draw triangles method with a texture, which is a decal. Give it the coordinates, the textures, and the colours. But let's just run it. Let's have a look and see what happens. Make sure I've got that startup project. So I've loaded a model here, which is obviously of a fairly famous computer game character. This is the tiling background demo. This is what I'm saying. It's two programs smushed into one. So we actually managed to sort of get rid of all of those tiling artifacts there. And this is Crash Bandicoot being rendered just with vertex colours at the moment. There is actually a texture there, and you can see the texture on his back is incorrect, and that's why it looks a bit strange. But this Crash Bandicoot being rendered at, well, on my screen at the moment, about 2,800 frames per second. That might not seem very high, but there's really sort of no overhead. This is actually genuinely the graphics card handling this transformation. And it's not doing it through this warped decals method either. So we are actually have a genuine Z buffer going on here too. I'll show you how it works, but it's going to need a little bit more work yet, because I need to think of a way to package this nicely for the end user. Chocolate and milk, hello, Fat Wee Wee 420. Thank you. Demo scene music plays, yes, Annie. Yeah, I think that's what we'll just end up with, people having spinning logos all over the place. Basball, hey, baseball, hello. So what I didn't want to burden the user with here is actually sort of maintaining all of the geometry themselves. So in the Pixel Game Engine, I'm going to provide some fairly basic utility functions. Remember, this is just to provide a lightweight 3D interface. And if any of you have been following Justin Richards' project recently, we rather coincidentally were starting to work on something quite similar. I was doing some top-down 3D stuff using the warped decal technique, and realised very quickly that actually it doesn't work very well. The downside to this approach, though, is I don't know how to handle things like lighting and stuff like that, and you'll see why in a minute. Hang on, just gone ping. That's not too important. So I'm going to have a drink. Tonight's drink is strawberry milkshake. If there isn't a vertex buffer, are you passing the vertices to the GPU again each frame? Yes, in essence. Yes, we are. So potentially, this is where we need to start thinking about where the division of labour is with the Pixel Game Engine, because basically the function exists in draw decal. Now, this isn't draw decal that the end user sees. The Pixel Game Engine has something called a renderer. And the renderer implements what actually draws the thing to the screen. And so for decals, it happens to be this draw decal function. And so we're going to be looking at a bit of OpenGL code here. Now this is OpenGL 1. So we're not using shaders, there's nothing like that going on. And so if I've got this special mode activated, the first thing I'm going to do is, well, I've got to sort of set up the projection and the model view matrix in the fixed function pipeline of OpenGL. We're going properly old school here. Oh, and you're going to love stuff like this. Oh, this is brilliant. I love this functionality in the C compiler. I think hash pragma comment lib, that should be universal across all compilers. But once I've established what these matrices need to be, I can then use sort of the basic OpenGL functions to do all of the hard work for me. So I can set up depth buffering, I can set up the perspective matrix quite easily. Right now I'm doing this every single time it draws a model, which is, because it's a work in progress. I need to sort of make it a bit smarter than this. And just to get it to do interesting things, I can rotate it, I can translate it, and that's how I'm using time get time here. With people groaning and rolling their eyes and all sorts. That happens to exist in that library, so that's why I'm just I'm including that there. If you don't know what that does in C++, it basically links the library for you. So rather than having to mess around with your make files or anything like that, you just throw that in your code where you need it and it'll do the rest. And then I tell OpenGL that I'm going to be rendering a set of triangles, and I pass in the information. Now, all of that information was already there in the Pixel Game Engine to begin with. Decals have tint information, the colour. They had texture coordinate information, and they had position information. They also had a W component. And that was used in the warping transformation. So I manually warp stuff using the W component for the draw warped decal functions. But in this instance, I'm actually using the W component as the Z component. So nothing needs to change. Hal Valor, hello. Oh boy, here we go. Oof! I don't think this deserves an oof. What's wrong with having this sort of in the middle, in the middle of your function? I think that's great. It saved me having to scroll to the top of the file to put it there. Right? It's easier just to do it where I need it. And so that's it, really. So there's not a huge amount of change there to the Pixel game engine itself to start leveraging these 3D components. Of course, if we're not in 3D mode, it draws the decal as regular before. Yes, Stuffy, I guess they do. I think it's a nice way. I think it's a nice way to do it, right? It's very, very controversial, I'm sure. Very divisive. So the changes that I want to make it. So let's go back up to I've started to sort of sketch out some functions that I'm thinking are going to be here. So all of these are going to exist in this sort of experimental lightweight 3D routines. And right now the function that you've seen me using is this draw triangles, which I just discussed, takes in a vector of positions, textures and colours. And then I need to start thinking about sort of other things. Remember, the target audience of the Pixel game engine isn't necessarily somebody that knows how to do 3D graphics. So I wanted to provide just a handful of utility functions. So things like set the camera to look at a particular target, set the camera to look along a particular direction, enable depth testing and particular orientation of face culling, stuff that you need, right? Got to have those things. I'm going to allow the user to just set the matrices directly. And I think I'll use these functions too. So when I set up things like the setting the camera, I'll probably call these myself to just set up the matrices manually, rather than relying too much on some of the OpenGL implementation to do that for me. Because I think once you've got these things set up, you want to reuse them. So you saw before I'm basically just doing it every single frame, every time I draw the object. That's only because I'm feeling out the code and want to see what it does. Yes, my attempts to avoid standard chrono. Well, that's that was it. You see, I was thinking, oh, I could go and get standard chrono all fired up. We could do this. Now, time get time. That'll do. Why not just make a timer system into PG2, PG3? I think that's probably something that will pop up. I know there's a few people already thinking of doing a PegX to wrap up chrono in something that's a bit more meaningful for game developers, I think. Tamitha 1987. Well, I'm having a guess that I know who that is, so thank you for the follow there, Tamitha. 1987, eh? Include a file in the middle of a function would be cool. We did that on the RPG series. I have Chrono hidden away behind my own timer classes. Yeah, exactly. I think that's how I'd like to do it. Nothing wrong with the actual functionality of Chrono, but it's just horrible to use. I think I did it deliberately. I even wrote the comment in the code. This is deliberately to annoy the pedants or something like that. Isn't as bad as standard file systems namespace. Oh, that's a mess. Yeah. I don't like the experimental stuff sort of contaminating everything either. So, lightweight 3D, is this a thumbs up or a thumbs down for Pixel Game Engine? Is it sort of outside the scope of what Pixel Game Engine should be? Now, bear in mind the following, and this is an important point. I would far sooner have all of this be an extension to the Pixel Game Engine. But right now, there's no functionality built into PGE which allows you to actually do 3D graphics. So if nothing else, these are going to be sort of all the functions you get. And you still need an extension to provide all the useful stuff, like loading up object files, loading up and applying textures properly, calculating normals, manipulating the geometry. Perhaps you want to add some matrix classes and that sort of thing in. All of that can exist in the PegX. All I'm doing is providing a break-in set of routines that allow you to, in some way, have some basic 3D graphics. Lighting and things is where the problems start to form. Well, one of two problems. My original intention was that you basically you're going to be manipulating the geometry still on the CPU, so you can actually do lighting on the CPU too by using changing the colours of the vertices and the transparency of the vertices, that sort of thing. Fine, I think for most people that's probably sufficient. But it does make me think that, well, the OpenGL 1 spec actually provides lots of utilities for very basic lighting anyway, so should it be abstracted in a way or not? I'm kind of against that one, I think, at the moment, because of problem number 2. And problem number 2 is a little trickier one to solve. Right now, this is using the OpenGL 1 implementation. But the Pixel Game Engine has 2 OpenGL implementations. Let's go and have a look. Oh, that was actually a lucky place to stop there, because the OpenGL 1 implementation of the renderer, let's find where it begins. So this is actually, yes, OpenGL 1. We also have the OpenGL 3.3, which allows us to have shaders, which is necessary for the Unscripted plugin and sort of doing more advanced things with the Pixel Game Engine too. So if you didn't know there was actually an OpenGL 3 renderer, there is. It's there. It works. It's functional, and at the moment it's functionally equivalent to the OpenGL 1. So you can quite happily select between the two. You get exactly the same behavior on both. And that's one of the challenges of developing the Pixel game, making sure everything actually behaves pretty much identically. The downside to this is you do need shaders, of course, for OpenGL 3 and beyond. So we have to provide all of this sort of clutter to compile the shaders. Now let's have a look where the shaders are. So we have to find all of these functions to load stuff up, and here we've got the shaders, and the shaders themselves are dependent on things like whether it's running on ARM, so this was for Raspberry Pi, or if it's running in Unscripted, you need to use a slightly different type of OpenGL. In this case it's OpenGL ES, but the rest of the code is fine. And the shaders themselves have some fairly interesting things going on. I have pointed this out before. Where was this? That I take my position and sort of do some interesting inversions before rendering it to the screen. And I'll let the maths aficionados go and maybe have a look at that one and work out why. There's a bit of a trick going on. And of course this then handles all of the vertex buffer stuff and the attribute buffers and everything else that you need to get shaders up and running. So yes, if you didn't know, the OpenGL 3 renderer, I mean, you can go and create your own shaders if you wanted to go and try and play with them. In fact, that's exactly what the Hardware 3D PegX that I'm working on behind the scenes goes and does. Well, it's actually a little bit smarter, this one, because it goes and tells the Pixel Game Engine how to load this particular renderer. And can add some additional functions to what it needs to load. Because this is loading the absolute bare minimum in order to function like the Pixel Game Engine, not provide a whole suite of utilities for actually rendering complicated 3D shapes. So, lightweight 3D. Definitely a thumbs up. Yeah, so okay, there's an interesting debate there. Not tempted to move to OpenGL 3 as standard. I think for Pixel Game Engine 3 we may do, but it's actually slower. Yeah, as Morris points out, OpenGL 1 is better. Wouldn't you still have to tinker with the inners of PG for proper 3D graphics? Yes and no. As soon as you've gone to a shader-based model like this, you just send it a different shader program. And structure the data how it goes down. So PGE will set itself up one way and send its data in the way it needs to do, but it'll then allow the user to go and do it any way they want to. One of the principles of the Hardware 3D PegX and my shader PegX indeed is that they render to decals. So you've created your decal, it exists in your GPU memory. That actually becomes the target of your 3D render, and that's really cool actually, because it's then a texture you can use in your 2D games however you want. So you can use all the established draw decal routines to start manipulating how this screen is drawn. So the question was asked earlier, can you sort of do split screen multiplayer? Well, that's one way to do it. In 3D, you would render to the different target decals and then render the decals to the screen. I found it quite an intuitive way to start thinking about 3D graphics, actually. I liked it a lot. Can you elaborate on what you mean by GCC headers being a mess? Oh, I'm not getting involved in that one. Shader toys, your new favourite thing. All the if-def macro monstrosities, it's pretty horrendous. Well, it's not as bad as it was. This is because it's purely because of Unscripted. Unscripted has slightly different requirements on what constitutes a shader. That's actually a concern, and this is why there's a problem here with the lightweight 3D implementation. Right now, both the regular 2D rendering and the 3D rendering use the fixed function pipeline. The graphics card doesn't really care; it doesn't see any difference. But as soon as you start using the OpenGL 3 rendering system, I've got to change that shader program around, because this shader here does useful things for drawing 2D quads and decals, but it's not very good at drawing triangles that are lit and coordinated. At least I don't think they are yet. So we need to have a think about whether this shader is even appropriate. And there's an overhead in swapping shaders around. So that then changes the nature of how we queue up the information and how it's displayed on the screen. It might be that there's no longer feature parity. Need to have a think about that. Code life is on. No idea what that is. Some Linux thing. No, Javid, that was about the GCC headers. Don't know. I've obviously lost track of the conversation here. I'm going to have another slurp of milkshake. Strawberry. Nice. So, lightweight 3D, I think it's a thought in progress rather than a work in progress at the moment. I think it needs a little bit of work, but I wanted to get a 3D API that didn't rely on all of the regular stuff that people use for 3D graphics. Simply because I think it's not aimed at that. If you're going to be creating your own sort of full first-person shooter engine and things, this is not the right way to do it. If you wanted a special effect, which was some spinning diamonds over your sprite, or some sort of interesting manipulation of the background scenery, or indeed actually having 3D models in your levels and that sort of thing, this is sort of more what it's for, rather than full-on 3D games. It's there to sort of enhance the 2D aesthetic, but with a bit of 3D. Shading the binding overhead can be minimized by making sure whatever is rendered is sorted. Yeah, but that therein becomes a bit of an interesting problem for the Pixel Game Engine, is that the rendering order is very important to the Pixel Game Engine. So it renders all the sprites happen first, then everything that's considered a decal gets rendered next. But because I'm using the decal sort of data subsystem to handle the 3D data, yeah, does it mean that I need a third subsystem? So does it do CPU rendering, then decal rendering, then 3D model rendering? I don't know. At the moment, unsure. These are things I need to go away and ponder and talk to the PGE elders about as well. Shader binding overhead. Oh, I've just read that one. What sort of overhead do you see on the shader bind? Tiny, if only a small number per frame. I think it's like all things in proportion, isn't it? The problem you have here is that every time you render a decal and then render a 3D model, it's got to make that switch. So it becomes very dependent on what the programmer's choice is doing. Now, as smart programmers, we should probably try to batch things in a sensible way to make it more optimal. So I can easily make the system detect if it needs to change the program or not. But if the end user is going, right, I'm going to draw this decal and that 3D model and this decal and then that 3D model, then there's going to be a problem, I think. Particularly when you get up to the thousands of models and decals. So yeah, there we go. That's what I have been working on over the last sort of week and a bit since we last spoke. Quite a few things, different little programs, and yeah, starting to think about making the Pixel Game Engine into a, well, I guess a genuine sort of game framework. Even though it's going to be a lightweight one. I don't want it to sort of make too many decisions for the end user. That's never been the point of the Pixel Game Engine. But when you see that nearly everybody that's using PGE now is using Transform View, you kind of think, well, that's a useful utility. People are using it. Maybe Transform View should be intrinsic to the Pixel Game Engine, and it will be for 3. So, a bit different there. So, lightweight 3D is a thumbs up. Excellent. Good. I'm pleased about that. I think it will be pretty useful. Particularly also useful for one of the projects I wanted to try and get a video out of this year. But we'll see. So, well, we're out of time. So being completely unprepared for a chill stream, I know, sorry we've not sort of pushed forward with a space thing, but that's not gone too bad. And we should be back to normal next week, I think. Oh, hang on, no, next week. Am I going? Even might not even be a stream next week. Next week is it's a milestone birthday for Mrs. Javid X9, and I'm actually going away for a week. So maybe not. Undecided. I'll keep you posted. I needed to sort of also work out. Did the bot announce the stream at all? Let's have a look. Oh, it did. Excellent. Oh, good. Okay, so the bot is working. A milestone birthday is it's a birthday of an important number. She wouldn't want me saying live on stream. Okay, with that, thank you for those who have subscribed and resubscribed, and thank you for the follows. I know it's not been a particularly coordinated stream tonight. We'll get it. Yeah, come and have a chat on the Discord. I'll see you next time. And hopefully Twitch will still be here in a week. Who knows? May have to move over to YouTube entirely. All right, take care.